So we have another form for parabolas. We've learned parabolas in a lot of different ways. This form took me some getting used to, but it's actually really nice once we get used to it. So it makes sense if we have y equals x squared, right? That was the first parabola we learned. That goes up if it's positive, and then if it were negative x squared, it would go down, right? And if you have x equals y squared, you get to do sideways parabolas. So right if it's positive, left if it's negative. It makes sense. It works. So what we're going to do is all of these guys have their vertex at the origin. None of them are shifted. So they're all at 0, 0. And when it's written in this form, that 4p is just that coefficient right there. So 4p is 8, and what that is, it's the focal diameter, the length across the focus. We'll do that in 2 seconds. And then if you just divide that by 4, if this is 4p, divide that by 4 to get p is 2. And that's the distance from the vertex to the focus, which is also the distance from the vertex to the directrix, I should say. All right. So when I go to graph this, I know my parabola faces up. So with a vertex at the origin, my vertex to focus distance is 2, so up 2. And my focal diameter is 8, so 8 across, 1, 2, 3, 4 on this side, 1, 2, 3, 4 on that side. And that makes my parabola kind of fat. Whoops, you missed. So my focus I can see is 0, 2, and my directrix is that same distance p the other way. So if I go 2 down, I have this directrix here, and the equation for that line is just y equals negative 2. And yeah, I go into another video about what it means. Every point on this line is the same distance from the focus as it is from the directrix. So this point is the same distance from the focus as it is from the directrix. This point, same distance from the focus as it is from the directrix. So, but just getting the points, not so bad. We'll do it again. So, oops. All right, so we did number 1, and now for 2. Y squared, so I know I'm opening to the right. Vertex 0, 0, the 4p is 12, divide that by 4 is 3. So if I'm opening to the right, my focus is 1, 2, 3 this way, and my directrix is 1, 2, 3 the other way. And my latus rectum is 12, so 6 on either side. So 1, 2, 3, 4, 5, 6 that way, 1, 2, 3, 4, 5, 6 that way, and there is my pretty graph. So the focus I can see is the point 0, 2, and the directrix now this line is x equals negative 2. It would be a lovely equation for that line. That's that. We're going to do it again. So all of this goes away. Alright, let's give it a different color. So, this one, x squared, so it's up or down, but because it's negative, this guy is going to go down. Vertex still at the origin. The latus rectum is 4 long. The p, divide that by 4, is 1. So since I'm opening down, my focus is 1 down, and my directrix is 1 the other way. My latus rectum is 4 long, so 2 on either side, and I graph my parabola. So I can see that the focus came out at 0, negative 1, and the directrix, that line is just y equals 1. Awesome. We can do it again. Alright, last guy. Let's see. So since it's y squared, that's a weird one. It's either opening right or left. Because it's negative, to the left. The latus rectum is 1. There's nothing there, so we know it's a 1. Divide that by 4, I get a 4th. Kind of a bummer, but that's okay. So my focus is inside the cup of my parabola, so 1/4 this way, and my directrix is 1/4 the other way. The length of my latus rectum is 1, so a half on either side. So I get this skinny little parabola there. So that length there was 1. So my focus ended up at negative, what is that, negative 1/4, comma 0. And my directrix, the equation for that line, would be x equals 1/4. There you go.